Welcome to Dreamforce 2017, your first session. Isn't that great? Come on, come on. Awesome. We start with this very first exercise because it's 8:15 in the morning. So, how many people see a banana here? Raise your hand. Who's seeing a banana? Okay, who is seeing a shelf? Good, a couple. Next test. How many pictures with fruit are on here? Too late. Can I change my credit card? What is it? Is it a support case? Which team should it go to? You have 2 seconds to decide. Find the same case here. 2 seconds. And that's why you're here in my session. That's why you will learn, and this is a key takeaway, how Einstein Platform supports you to automate your processes around everything that is vision related and everything that is text related, where people have to make a decision in their business. My name is René Winkelmeier. I work as a developer evangelist with Salesforce. I focus on AI, on enterprise integrations, mobile security, and a couple of other things. So what you will learn is Einstein Platform Services, the basics, and you will also learn that I say Einstein, right? US people say Einstein. No, it's Einstein, just to be very clear on that. The second thing is you will see Einstein Platform Services in action in force.com. Who has played yet or investigated in Einstein Platform Services? Someone played with? A couple. Okay. So so you have to differ. We have Einstein in product, in lead scoring, automated case routing, and many other services, right? Where you just switch it on in the product, you pay for it, and you have built-in functionality. But we also offer a variety of services via an API, basically in vision and language, which are the two umbrella brands that you can incorporate in any application. That can be in force.com, that can be in a native iOS app, that can be in your on-premises Java application. We don't care, right? We offer an API and you can apply that. So we have vision. Vision contains image classification and object detection. So what does it mean? You remember my banana picture from before? You classify that image as an image with a banana. Or you classified it as an image with a shelf or a bowl with fruit. Right? So based on an image, you can classify that. Just imagine what use cases you have in your companies where people have to make a decision based on something visual every day. What kind of machine is that? Is this broken, for example? Object detection is a very new service that we're offering now in beta, and that service allows you to detect objects within an image. So you can count the number of objects in an image, like products in a shelf, for example. The second part that we're offering is language. And these are the services intent and sentiment. Sentiment is basically the text that you're getting, a positive text, a neutral text, or a negative text. What's far more interesting is, in my opinion, is intent. You have business cases like incoming service requests, and someone has to decide, is this change my password, I want to recall an order, or something else. And based on that, Einstein language intent automatically can classify this text as a category, like support request, and you can then apply that, for example, in Service Cloud, to route that to a specific service agent. But we will see it in action. So remember, vision and language with the two sub areas, image classification, object detection, intent, and sentiment. So when you first look at our documentation, you will see, what the hell, 45 API endpoints? No, that's huge, right? You have to learn all that, all those subparts in that, and it is not that hard. It is really, I wouldn't say simple. Simple is a bad word in this case, but it's really easy to start with it, and you will learn the basics. So coming back to my banana, first you have to work around the data, and the most important thing when you work with any AI is to have good data, because you feed the machine with the information that this is a banana, or you tell it that it's a shelf or a bowl with fruit. You have to specify the data and to classify up front. I always, it's like with my kids, right? I have 3 kids under 5. Yes, I know it's busy, right? It's busy. And they ask me every day, Dad, what is this? What is that? And I take over the part of classification for them. I tell them, that's a banana. That's a banana and a shelf. That's a wooden table. This is blue, right? All those things. So I classify visual parts for my kids. And based on that, they apply that to future decisions. And this is basically what Einstein Platform is doing, right? You classify data up front. It is then able to detect the pattern in images or in text that it hasn't seen before, and then can make a decision to classify it as something. And we call that the term in Einstein Platform as an example, and you give it a label. So the label would have been, for example, banana or shelf. So the first term to learn, example with label. So then you have a group of those examples, because you can't just feed the AI with one image, right? So you have to provide 50 images, 500 images, 50 versions of text, 100 versions of text. You have to play with it, how good the result is. And this group of labels is what's called a data set, the second thing that you will learn, right? So you have examples, and the group of them are data sets. So how many do you need? It depends, honestly. I have image classification examples with 15 images, which were great. If you have, for example, products that you want to compare and they have only subtle differences, you may need 100 or 250 or 335 images of those, right? From different angles, because the machine can just apply its prediction as good as the data that you feed. There's a saying in German, I can't say it because this is recorded, but you probably know. Good, bad stuff in, bad stuff out, right? So that's how it is. So example, data set, and the next thing is the model. So when you have all your data collected, you upload that, and you will later see how you can do that. You will create a specific version of this data, and this is what we call a model. This is how Einstein has learned your data and its applied labels at that specific time. So why is this important? Because at a later point you want to predict an image, or you want to predict text. So, and you do this later based on a model. We call that then prediction. And this returns the probability and the label based on given data for a specific model. Hard to understand? You will see it's really, really simple. So you have your data, you say, learn, Einstein. At some point it says my training succeeded, and based on that you pass the model ID, the identifier for the model, and based on that you will get your return results. And this is really interesting when it comes to later, when you have to refine, for example, your predictions, because they will work for 85%, and 50% will be maybe not that great. Why? Because you need more training data. So, but that's enough slides, right? We want to see some code. Who is a developer here? Want to see some code? Great. So let me hang on. I have to finish the presentation mode, and then we will see some code. So first of all, I offer an open source project, Einstein Playground, where you can get your hands on, just play with it, and it includes all the code that you need. I mean, you read before 45 API endpoints. Who wants to write all that Apex to communicate with it? Raise your hand. Who wants? No? No? One person. Okay. So lucky you, I did it for you. So I give you a simple example how that can look, for example, in a Lightning interface. So when you want to upload your data, you have to provide the data, or you can provide the data in a zip file, which I'm doing here. On a remote URL, this is the example image that my colleagues from the Einstein product team provided. And just with the playground, I am just creating the data set, which then gets uploaded, and I'm using the same here, which then gets uploaded to the Einstein server. And as you can see, I have 50 example images of mountains and 49 example images of beaches in here, which then allows me later to predict, if I pass an image in, is that a beach or a mountain? Does it sound interesting? We can try it, right? We can try it. So let's see if I go to my prediction, how it would look like. So I have my predicted beaches and mountains image here, and it contains two things. It contains first the data set, and second the model ID. You remember I said if you want to predict something, it predicts to a specific model ID. So I'm now a nice guy. I have my banana image, and I want to train that against beaches and mountains. So let's see what's happening. So as you can see, this banana is with 67% probability a mountain. You're wondering why, right? Well, because I trained this specific model only to recognize beaches and mountains, right? So it has never learned to compare anything else. So it tries to apply this pattern to the image that I fed. Which then means, well, if you want to specify, or if you want to detect multiple different elements, you have to provide this data. So let's make it more useful. There's also a pre-built food image classifier. Well, that happens when you don't change that one. Hang on. Our general image classifier, let's see what happens when I then feed the banana in here. And this looks pretty much like how we want to have it, right? So with 98%, this is banana. And this is a model that the Einstein team has just trained to detect a variety of services. Now think about your products that you may want to identify, right? And the output of this is just a simple REST call. You get a probability of 0.98. It's a float, so that's 98%. For everyone who's wondering why the number is so low. And the other probability for a bathtub, a bathing tube, is 0.1%. So it's pretty clear that you can automatically detect that. Is that cool? Who has vision detected use cases in his company or her company? So what I had an example was I met a guy in Amsterdam, and they are sending around people to read those power numbers. I don't know this in English. The go from household to household and check how much power they used, right? And those people also check the cables. Are the cables in a good condition or in a bad condition? But because they are volunteers, they are not experts, right? So what they are doing is now they train Einstein with images of good, with cables in good, bad, average condition, and those volunteers just take a picture of that And based on that, the company knows how are the cables. Should we send someone to fix or not? Right? So there may be use case in your company where you don't even think about today that you can use something like Einstein Platform. So what I really, really like is our new offering, object detection, which allows you to detect, as I said before, object within an image. So what I did here is I created a data set with our mascots Astro and Cody. So I took a couple of pictures of them, and this is basically use case in the CPG industry. So if everything goes well, you will see now where in this image is Astro and how often I will find an Astro in this image. And this is not fake, right? So you can see the code, so it's automatically generated, right? And what happened here is that based on the pattern of only 7 images, only 7, not less, images that I provided for this data set, now Einstein Object Detection was able to give me a bounding box, like where is Astro in this image, and that it is Astro. So this kind of information, the bounding box, the labeled probability. So why is it important? So you can, with this, detect the exact amount of objects in an image. People in customers, for example, detect that, use that for how many of my products are on the shelf. Is a competitor there that shouldn't be in there? Did people set it correctly up? And many other opportunities. You can also go to, I think, to the AR booth over there, where my colleague Philippe has something built in the AR. The next thing could be to go to language intent. I'm just skipping because I want to show you some code. So this is where we trained Einstein language intent with possible sentences of how people would ask for an order change, what could be a sales opportunity, a shipping info, password help, and so forth. So when I enter a simple phrase like, can I change my password? I hope it's right, sir. So I'm getting a 100% probability back that this sentence is about password help. And then you can route that. An example. You can also monitor social media and see if a customer requests something via a Twitter feed. So coming back to the code thing, the question is how much code is really needed to write all this? I mean, it's a full API, it has a dozen of parameters. You may have to learn that, but using Einstein, using the Apex wrappers that I provide, you can very easily communicate with the API. So this is the controller that's used for the whole playground. And for example, if I want to predict the intent, which I just did, you have only this 3 lines of code, right? First of all, it is about, hang on, large enough? For those on the last row. First, you define a type, because the wrapper handles all different APIs that we offer, object detection, image classification, intent, and sentiment. And then you just ask a service to predict the intent. You give the model ID, the text phrase, you don't need the other parameters to be honest, and that's all you need. You can also embed this code, if you want, for example, in Process Builder. Who loves Process Builder? It's great, isn't it? So what I did here is I'm using the same code in Process Builder in an invocable action so that administrators can use that without using a single line of code in Apex, right? I mean, that's where the world goes now today. So I have a single invocable method, Einstein image classification, which takes a couple of parameters, and based on the value of a field in an account, Einstein goes here, takes a remote URL, and predicts based on the remote URL the intent. Is it usable? I have a customer, for example, I met them last week. They're uploading pictures of machines to the chatter feed of the account object. And every time the person out who's doing this, the field guy or the field lady, needs to classify, is it now machine A, B, C, needs to add some data. And this process is now fully automated because they're using Process Builder to monitor the chatter feed and just automatically running the classification. And no one has to make a manual decision based on that. Questions so far? I try to hear you, yes. Yes. So the question is, when Einstein learns this algorithm, is it only for you on your single account or for everyone else? And the answer is, it's only your single account. It's your data. You have a single access with a personalized account, and that's what Einstein is learning, your data. So you can't share so you won't be able to share it with others. Let's put it that way. We have more questions. No more questions. I think you better come over here. I can't hear that far.
You had a data set for mountains, beaches, and then you added food. Was that in the same data set?
No. So the question was beaches and mountains, and the food was in the same data set? No. So the example that I have here is, which image classification is, we have a couple of pre-built classifiers so that you can directly get hands-on and play with it. You can later add, if you want, for an example, to an existing data set, more labels. Like if you find out, oh no, we're adding another machine, for example, you can then add that.
So I mean, you said you need to classify your data, and so would you classify your data as mountains, and then classify your data as beaches, and then classify...
Exactly. So for the image classification, in this example, you build up your set of example images per category, per label, and then you, based on the label, you upload that in a data set, because a prediction runs always against a data set.
So for identifying images, would it be standard to actually use recursive data sets to refine the match? So say you had a larger data set of food or places or mountains, beaches, and then from there you could actually drive into, okay, this is food, so I load in another data set, fruit, cereal, things like that. Would that be a good use case for this, you would say, or is it better to just use one massive data set?
Right, so the question is, would it be more appropriate to have multiple smaller data sets based on your data, or a huge data set? So personally, I would say it depends on the use case, right? So if you have the simple example over here, beaches, mountains, and food, I would likely not put that in one data set, right? Because it's just not the same category, right? And it all depends at the end on your use case. I wouldn't put it with beaches and mountains in this case. That wouldn't make sense. We don't care at the end how large the data set is, right? But you may have different data sets based on your different use cases. No. So this is available right now. You can find it on the Einstein Trail Mix, and the wrappers are also already available. All the services are available. Sign up for those. The Einstein Trail Mix leads you to the Einstein Platform Services sign up page also. Thank you very much.